Hello everyone, it's pretty cold out here where I am, and I can't do much about that. But what I can do is solve merge case sorted lists for you. Now, this question is something that we are a little familiar with because in the previous video I solved a question. I solved a question which was named merge two sorted lists. So my intuition suggests that maybe we can use something that we studied in that video to solve this one. So if you haven't watched it, I suggest that you do so first, then come over here. That would make understanding this question, which has been labeled as hard, you would understand it in a much simpler fashion. So without further ado, let's focus on what we have right now. In this question, we have been given k linked lists, and each linked list has been sorted in ascending order. We have to merge all of these k lists and return them as a single list. All right, and of course that list has to be sorted. Now, understanding it with an example, we have five lists over here: one, two, three, four, and five. Okay, we have to merge them. As I suggested with the hint that I gave earlier, that we will use the knowledge from the previous video to solve this one. So again, go do watch it and then come back here. All right, we have k lists. I say that instead of trying to solve all k of them together, let's break our problem down into smaller parts. And as you would have picked up by now, we will do that by solving them two lists at a time. All right. So what we're going to do very simply is take two lists, right, that are right next to each other. So these two, then these two, and if we have an odd list left at the end, we will simply pair it up with a null value. So if we decide to merge two lists, which we already know now because we have seen the previous video, the answer would be 1, 4, and 5. All right. And then we move on to solve this one. That's one list, okay? And this one would give us 2, 6, and 8. And the last one, it is a single node and it is a single list. So we simply return this list as it is. That gives us 3. All right. So that is what happens in the first pass. Now we have to consider this as our input. Right. In the first input, we have to merge k lists. Now we have to merge these many lists. So we repeat the process exactly as we did, and we move on by taking these two together, and then this is an odd list left once again. So to solve them, after solving them, we get 1, 2, 4, 5, 6, and 8. And on solving this, we simply get 3 once again. This is what we get in the second pass. In the third pass, we have these two lists. We simply combine them, and as I'm sure you would be able to tell what happens now, we get 1, 2, 3, 4, and so on. Now we stop the process when we get one list remaining and we return its head node, and that is pretty much our answer. So in the next video, what we're going to do is we will implement this as it is, this divide and conquer approach. But before ending this video, I would like to discuss the complexity. So in every single pass, we have to ultimately compare n elements, right? All n elements that we have, they will be processed. So that gives us n over here. But if you notice, first we had 5 lists that reduced to 3, to 2, then to 1. And if it was an even larger list, maybe then you'll be able to visualize this better. But you're actually reducing a problem statement by half every single time. That gives us the complexity of n log k. This log k is given to us by this problem statement reducing its scope by half in every single pass. So that's n log k for us. In the next video, we'll implement this, which is where I'll see you. So stay tuned and follow for more.